So this first question says to multiply. We want to multiply 4.3 times 10 to the second times 5.103 times 10 to the 7th. There's a special note here that says the number of significant digits in the answer should equal the least number of significant digits in the numbers being multiplied. So we want to pay attention to those significant digits as we do the multiplication. We want to express this answer in scientific notation as well as in decimal notation. So when we do this multiplication, because we're multiplying it in scientific notation, we can multiply the numbers 4.3 times 5.103. So I'll do that in my calculator. 4.3 times 5.103. And that comes out to be 21.9429. And with the powers of 10, 10 squared times 10 to the 7th, because we're multiplying with the same base, we can add the exponent, so that's 10 to the 9th power. So we've got 21.9429 times 10 to the 9th. Now this answer is equivalent to the correct answer, but it doesn't follow the directions. We want to express the answer in scientific notation. And there are two basic rules with scientific notation, and you can see that these two follow those rules. The number part has to be in between 1 and 10. So both of these numbers are in between 1 and 10. And this power has to be an integer, like 1, 2, 3, 4, 5, 0, -1, -2, and so on. The number that we have here doesn't follow the rule because this number is not in between 1 and 10. So we have to make an adjustment. So we're going to move the decimal place one place to the left, and that makes this number smaller, so this one becomes bigger to compensate for it. So we moved it one decimal place to the left, we added 1 to the power because of that. So we can eliminate these two choices because they have the wrong power on our 10. And then we need to think about significant digits. So this number here has 2 significant digits, and this number has 4 significant digits. We cannot be more accurate than our least accurate number. So this is our least accurate number, and so our answer should only have that many significant digits as well. So our answer will only have 2 significant digits. So we round that 2.19429 to 2.2 so that it only has those 2 significant digits. We have our correct answer of 2.2 times 10 to the 10. Then we also want to express our answer in decimal notation, and so we're going to take that 2.2 times 10 to the 10, and we're going to move our decimal place 10 places to the right. So we have 2.2 with a bunch of zeros. How many zeros? 1, 2, 3, 4, 5, 6, 7, 8, 9. One more there. So let's make that into groups of 3. We have 22 with 1, 2, 3, 4, 5, 6, 7, 8, 9 zeros. So this is the correct answer right here. For this question, we want to solve the equation absolute value of 5x plus 2 minus 6 equals 12. With absolute value equations, We do break it out into multiple cases to get the answer, but before you break it out into those multiple cases, you need to isolate the absolute value first. So first we need to add 6 to both sides so that the absolute value is the only thing on one side of the equation. So adding 6 to both sides gave me absolute value of 5x plus 2 equals 18. And now we want to think about the two different scenarios. Absolute value of a positive 18 is 18. Absolute value of negative 18 is 18. So there are two possibilities for this expression inside the absolute value. 5x plus 2 could be positive 18, or 5x plus 2 could be negative 18. We'll solve each one of these equations. I'm going to subtract 2. I get 5x equals 16. Divide by 5, and x equals 16 over 5. I'm going to subtract 2. That gives 5x equals negative 20. Divide by 5, and x equals negative 4. So the two solutions to this absolute value equation are 16 over 5 and negative 4. On this question, we want to solve the formula a equals 1/2 h times a plus b for b. That means we want to isolate the variable b on one side of the equation. Now this fraction can be a little bit confusing, so I'd like to get rid of that first before I start breaking up these parentheses and solving for b. So to get rid of this fraction of 1/2, I'm going to multiply by the reciprocal of 1/2. That's 2 over 1, or just a 2. I'm going to multiply 2 on the left-hand side, multiply by 2 on the right-hand side. This is going to get rid of the fraction. Multiplying by 2 and dividing by 2 are opposites and they cancel, and that leaves me with h times a plus b on the right-hand side. Then on the right-hand side, I want to break up the parentheses with the distributive property. That would give HA plus HB. Remember, this is my goal variable that I'm trying to solve for. I'm going to subtract HA on both sides. I have 2A minus HA equals HB. I want to get B by itself. I'll divide by H. And I have my rewritten formula, 2A minus HA over H. If you'd like, you could take it one step further and break this up into two individual fractions instead of one fraction. That would be 2A over H minus HA over H. And these H's can cancel. So you could write this as 2A over H minus A. So either one of these answers is acceptable. On this example, we have t of x equals absolute value of x, and we want to graph it on this Cartesian plane. The way that we graph an equation like this is with plotting points. We're going to choose x's and find the y's. And I'm going to choose x's of -2, -1, 0, 1, and 2. These are my standard set of x's that I choose, have some negatives, some positives, and 0. We'll plug them into our equation, which is absolute value. Absolute value of -2 is 2. Absolute value of -1 is 1. Absolute value of 0 is 0. Absolute value of 1 is 1. Absolute value of 2 is 2. This gives me a set of ordered pairs. I have -2, 2, -1, 1, 0, 0, 1, 1, and 2, 2. So this tells me the shape of the graph, and that's a V-shaped graph. So this is the graph of my absolute value function. And with that graph, I want to know the domain and range. I can use the picture to help me with the domain and range. The domain is the set of all the x's. So looking at this picture, my x is this horizontal axis, and all of these x's are a part of my graph. You can see the line covers all the way across the whole number line. So that means my domain is all real numbers, and we can write that as negative infinity to infinity. So that's covering the whole number line. The range is the set of y's, and my vertical scale is my y, and my lowest y value starts right here at 0, and then all of the rest of the y's are covered. And so we'll say to infinity. From 0 to infinity is my range. You'll notice that I used a bracket next to the 0, and that indicates that the 0 is part of the set. So you can see right here we do have a y value of 0, so we should use that bracket to include it. On this question, we want to solve the equation by the quadratic formula. List the solutions separated by commas. So let's start by identifying what the quadratic formula is, since that's the method we're supposed to solve with. And the quadratic formula is something that we use to solve any quadratic equation. And the quadratic equation needs to be in the form ax squared plus bx plus c equals 0. It has to be written in that form so that we can identify what a is, what b is, and what c is. These are the values that are used in the formula. So the quadratic formula gives us the solutions to that quadratic equation as negative b plus or minus the square root of b squared minus 4ac all over 2a. So in our example, we have 4k squared minus k plus 9 equals 6. This is not the correct format to use the quadratic formula. So first, I need to rewrite it so that I have 0 on one side and all the terms on the other side. So I'll subtract 6. That's 4k squared minus k plus 3 equals 0. Now I have it written in the correct format, and I can identify what the a, b, and c are. A will always be the coefficient of your squared variable. We have k squared, so a is 4. B is always the coefficient of your linear variable, so we have k, negative k there. B is negative 1. And c is the constant. It will have no variable, so c is 3. We're going to substitute these into that quadratic formula, and that will give us negative 1 plus or minus the square root of negative 1 squared minus 4 times a times c all over 2a. So these are the solutions, but we need to make them in a simpler format. So we're going to use order of operations to simplify. We'll simplify the double negative to be a positive 1. Inside the radical, I'll apply the exponent. Negative 1 squared is a positive 1. And then we have 4 times 4 times 3, and that's 48. So we have a minus 48. In my denominator here, I can see that I forgot to write what a was. It's 2 times a, that's 2 times 4. So 2 times 4 is 8. can simplify a little bit more inside the radical. 1 minus 48 is negative 47. And inside the radical, we have a negative number. Square root of a negative is defined to be I. Square root of negative 1 is defined to be the imaginary unit I. And then the number 47 is a prime number. It has no factors other than 1 and 47. And so we can't break down that radical anymore other than handling that negative. So we can write 1 plus or minus the square root of negative 1 times 47 over 8. The square root of negative 1 is I, so we have 1 plus or minus I square root of 47 over 8. So these are those solutions to that quadratic equation. 1 plus I square root of 47 over 8 and 1 minus I square root of 47 over 8. For this question, we want to solve the equation by completing the square. Once again, we have a quadratic equation, z squared minus 10z plus 33 equals 3. And we want to use this method of completing the square. With the method of completing the square, the first two things that you want to do is to isolate the variable terms onto one side of the equation. And you want to make sure that the coefficient of the squared term is a 1. So the first thing that we're going to do to this, z squared minus 10z plus 33 equals 3, is to subtract 33 on both sides. That gives z squared minus 10z equals negative 30. So we did that to isolate those variable terms, and then I already have a 1 in front of this squared, so I don't need to do anything else. But if this was, say, a 2, I would divide every term by 2 to force this coefficient to be a 1. Okay, once we get it to this state, we need to come up with a number that's going to make the left-hand side factor to be a perfect square. I usually call that the magic number. So on the side, I'm going to do a little bit of work to figure out what that number is. We start with this coefficient of the linear term, so I'm starting with negative 10, and you're going to divide that number by 2 and square it. This is going to give us negative 5 squared, which is 25. 25 is the number that's going to make the left-hand side factor into a perfect square. I want to add that 25 to the left-hand side, and my equation needs to stay balanced, so I'll also add 25 to the right-hand side for that balance. On the left-hand side, if I factor, you'll see that it's going to factor z times z is z squared. 5 times 5 is 25, and I need these to be negative, so I get a negative 10z in the middle. And so you can see that my factoring worked to provide me with a perfect square. So that's what that number, that magic number 25, is the right number to make this factor into a perfect square. On the right-hand side, negative 30 plus 25 is negative 5. And I can finalize my solving of this by getting rid of the square with the square root. The square root and the square are opposite operations. They cancel each other out. And I get this plus or minus on the other side. Last couple things here, get z by itself, so I add 5 to both sides. I have z equals 5 plus or minus square root of negative 5. And just like on that last example, I want to simplify this radical. We have square root of a negative, and that's I, that imaginary unit. So we have z equals 5 plus or minus I square root of 5, or if you prefer, you can write 5 plus or minus square root of 5 I. Just as long as your radical doesn't extend over that I. Solve the formula A equals 1/2 H times A plus B for A. I want to solve for A. So the first thing I notice is this fraction. I'd like to get rid of the fraction first. So I'm going to multiply by 2 on both sides. That's going to cancel out the 1/2. We have H times A plus B equals 2A. This time I'll approach just a little bit different. Last time I did a similar problem, I used the distributive property here. This time I'm going to divide both sides by H. That will cancel out this multiplication by H. We have A plus B equals 2A over H. And now I'll solve for A. I subtract B on both sides, and we get A equals 2A over H minus B. Thank you for checking out my videos. Have a great day.